A very good morning to everyone. Welcome to the Singapore Geospatial Week Plus series of webinars. So today, right now, we have Planet, which the Planet team, which will be talking about data for environment. We have with us two speakers, Jonathan Ong, Regional Sales Manager, Southeast Asia. And also he'll be joined by Kang Kian, Senior Solutions Engineer. So without further ado, we'd like to welcome both speakers from Planet to talk a little bit more about Planet's data solutions for environment. Jonathan, please.
Thank you very much, Azhar. So thank you everyone for joining. It's a privilege and honor for us to take part in just Geospatial Week Plus. So without further ado, let me just get on to talk about what Planet does and for data for environment. So just a quick introduction. So I'm Jonathan. I'm the Regional Sales Manager for Southeast Asia. I'm based here in Singapore. And with me as well, I have Kian, who is also based in Singapore, our Senior Solutions Engineer. So we will be running through with you, a little bit about what Planet does. And at the same time, I will talk, sorry, just give me a second. So I will just go through for the agenda on the overview on what Planet is all about. Then I'll hand it over to Kian, who will be going a bit more into our technical details, our constellations, and more importantly, and that's relevant for this today's session as well, our use cases. And at the end, we will wrap up with a Q&A. So in the meantime, while we are going through our slides, if you guys have any questions, please feel free to put them into the poll and Q&A chat box. We will be constantly looking at the questions and we'll be answering them at the end of the session. Okay, so let me move on. We here at Planet, we like to use this phrase where you can't fix what you can't see, but this phrase really doesn't just apply to what's here at Planet. It really applies to in your everyday life. So we kind of modified that phrase. We've changed it now to you can't fix what you can't see well. So we'll be touching a bit more on in recent months and weeks, how we've actually improved our satellite imagery capabilities and how we can bring these capabilities down to everybody who's able to access it. So in the geospatial or satellite imagery industry, the traditional challenges that we face is that we don't really have a very good reliable source of imagery that's coming down. So it's the lack of insight that we are unable to provide. So these are traditional challenges that over I would say decades since we've put satellites up there, we're just not able to do that. And usually what happens is that these lead to most of the time inaction, whereby you're not able to make a good decision from there. Or worse still, you make uninformed or bad decisions that could have consequences afterwards. So here at Planet, we have a different approach and we have a different way of thinking. We think that we want to provide insights at the speed of change. And what do we mean by the speed of change is that we're able to provide insights, monitor change that's going on a daily basis. So I'll touch a little bit more on that as we move on. So, how we're doing it. So Planet's mission is really to image the whole world every single day and to make this change visible, accessible, and actionable. So this is our mission, and I'm glad to report that we've actually accomplished this mission back in 2017. We've been able to image the Earth's entire landmass every single day. I'll go on a little bit more on how we did that. So what we are, Planet as a company, we are a satellite imagery provider that provides geospatial insights at the speed of change. So we do this by providing the most up-to-date satellite imagery through agile aerospace or agile infrastructure that we call it. With all this data that's coming down, we are building insights and intelligence on top of these data. And finally, we are able to deliver all this via building applications, APIs, and integrating with workflows of the choice. So we are really an integrated end-to-end company. We do our own R&D, manufacturing. We run and operate our own satellites. And it's been a long journey. about 27 rocket launches that we've done so far. So, before I go a bit more on, what Planet is all about, let me just talk about on a high level macro industry trends and changes that we see today. So the geospatial industry, the Earth observation industry and the GIS spatial analytics industry, as you can see from a report from this GeoBreeze report, from 2018 to 2020 there's an annual growth rate of about 15 and 12% respectively. So as you can see, this is projected to continue its growth. In the next, from 2020 to 2025, it's expected to grow at that rate as well. And of course, Asia Pacific is the fastest growing region, driven by the powerhouses, China and India. But of course, we can't discount the fact that the other countries in Asia, Southeast Asia, we are seeking to build and learning how to leverage all these data and to build up their GIS and analytics capabilities on top of all these data sources that we see in the market now. So to talk a bit more about the markets, how the markets has evolved. So firstly, the professional markets that has been around for decades now. The primary users and the customer base that we serve are usually of course, we have the defense and intelligence segments, excuse me, agriculture as well. So agriculture is a very big thing, and in the US, it's a pretty big market, and we see that now slowly trickling over to the Asia market. And of course, you have other segments like urban planning, natural resources monitoring, public safety, and disaster management, which it's very relevant in our part of the world. That's one of the use cases. So with all this data, we're actually building on top, analytics and business intelligence. Now, all this kind of insights can be worked on, and currently at the moment, I would say it's still predominantly done in terms of by humans. Actually doing the analysis, going through the data, and then from there, gleaning insights and intelligence. As we move on, with our increased, computing power through cloud adoption and scaling up through clouds, we're able to then put all this data, a huge amount of data, and then we're actually trying to automate it and make use of AI, machine learning, and we're moving towards the analytics, artificial intelligence kind of era right now. And really, that's the kind of natural evolution that we see, and this will only continue to get stronger and more reinforced, where businesses will incorporate all these new technologies as part of their workflows. So, given that this is the direction, let me just come back to what Planet is about. We came back to how we are doing it is really, through this term, we like to use agile aerospace. What does this mean? So in this picture that you can see here, it's actually a picture of our Planet scope doves. We call them doves. So this is one single plant. You see two of them there. So they're really the size of about a shoebox size. We call them CubeSat, so it's about 10 centimeters by 10 centimeters by 30 centimeters. So this is when it's folded, when you unfold them, they're no bigger than the size of a 14, 15-inch typical laptop. So that's the kind of size of satellites that we're building, and that's how we're able to build them really quickly, and put in the latest and greatest technology. And we keep sending them up. In the past few months, we've launched over 30 satellites. So that's the rate at which we are constantly innovating. And then our second approach is by democratizing satellite imagery. That means anyone and everyone should be able to gain access to it, just like, for example, Google Earth. And with this imagery, we provide, can tell a story. Images don't lie. So that's how we hope to everyone to gain access to that. And how we scale out and reach out, and to on a global scale, we are pretty much completely cloud-based, and that's how we're able to scale. So just a little bit of history of Planet. We were founded in 2010, so this is actually our 10 years anniversary. We were founded by ex-NASA scientists. They had this idea of turning satellites and turning it around and instead of looking out into the universe, turning it back down and look at what's happening on Earth, and from there be able to gain some insights to help things that's going on Earth. And then in 2014, our CEO Will Marshall went on to a TED talk, and he announced that we had our first mission, which is to image the entire Earth's landmass every single day. So throughout 2014, 15, 16, 17, we put satellites into space. And by 2017, we were proud to announce that, okay, we managed to able to image the whole Earth's landmass every single day in 2017. Then in 2018, what next? We had a bunch of data, a huge stack of data. What do we do? And that was when our second mission was announced of a queryable Earth. So what it really means is, just like an analogy given, is just like how Google indexed the internet and made everything searchable on the internet. We are trying to index everything that's happening on the changes that's happening on the surface of Earth and make it searchable. That's why a queryable Earth. And just some numbers so far, like I mentioned, Planet, we've been around for 10 years. We've had over 27 successful launches. We have put up 395 satellites into space so far in this past, since 2014 to now. And just to give you a bit of scale of the amount of imagery that we're taking 3 million images of the entire Earth's landmass every single day. Now that equates to about 15 terabytes of data being downlinked or coming down into our servers every single day. And that's the scale of data that we're working with. So we do this by through our 44 ground stations spread across the world. These ground stations are all owned, operated, and run by Planet. So we're pretty much an end-to-end kind of Earth satellite Earth observation satellite imagery company, and we run everything on our own. So through this 10 years that we've been in business, we've had some really big high-profile customers that are using our imagery. So as some of the more prominent ones, you can see NASA that uses our satellite imagery for research and scientific kind of studies. Farmers Edge is a very big precision farming technology company in the US where we talk about precision agriculture. And of course, Google as well, we have a very strong partnership with them in collaboration. They use our imagery as part of the Google Earth engine and many other users. We do have partnerships with governments. You can see Queensland government in Australia, New South Wales. We have other partnerships with customers that are top customers like BASF, chemical company, Bayer, Kairos, and so on and so forth. So the list is non-exhaustive here. So I will now pass on to Kian, who will go on a little bit more onto our satellite constellations, as well as go into some technical details, and more importantly, here some of the use cases that that's relevant to our region. So thank you very much, and Kian, please. Kian, sorry, I think you are on mute, Kian.
Thank you, Jonathan. Yes, can you hear me? Yes, I would like to continue the Planet presentation by introduce our satellite constellation. From the left, we have Rapid Eye constellation, launched in 2008, and since 2009, we have collect multiple image all over the world, and we have just decommissioned this year March. And in the middle is our crown jewel sensor. It's called satellite Planescope satellite constellation. Each of them, we call it Dove satellite, and currently we have 150 of them in space right now. And then we have our high resolution. When we say high resolution, it's a sub-meter resolution, and we have 21 satellites in the constellation. So I'll just go through one each of them in details. So our Planescope constellation consists of about 150 of them, and we launch them in that amount so that we can collect image over the entire Earth landmass every single day, and about 20% of the water body on Earth every single day. Each of the satellite, we call it Dove, is very small. It's about 10 centimeter by 10 centimeter by 30 centimeter. And we open up the solar panel, it's just like your laptop. We develop it, design it, and build it and launch it all by Planet. And we want to have a lot of satellites so that we can have daily revisit of our beautiful Earth every single day. If you look at other map provider, even the free source, they don't give you a daily kind of updates of satellite image. So when it comes to big data spectrum of the market, there is not enough satellite image from other providers, but PlanetScope do give you a daily revisit. And the resolution is at 3.7 meter. It's orbiting at SSO, Sun Synchronized Orbit, at the altitude of 476. Each DOF satellite lasts about 3 years, but in our recent design, it's increased our lifespan to 6 years. We are Agile Aerospace, and we already have 14 versions of this DOF since 2016, when our first launch. We have 3 major classes. We call it DOF Classic, and which is an initial 3 to 4 band multispectrum satellite image. And then we have a DOF R. R stands for refresh, is to enhance the collection to make the image sharper. And our recent version, we call it Super DOF. Not only that, improve in terms of the sharpness of the image, we also improve in the number of spectrum band. From our 4 band RGB near infrared, we add additional 4 band to improve the analysis accuracy, and we can improve in classification of the Earth better. Next is our SkySat. Total constellation design was 21, and we launched in different phases since 2013. We have launched our first few satellites till this year. And this year, we actually launched our last 6 satellites, and we make different kind of adjustment to meet the customer need. At this constellation, we are providing a ground sampling distance of 65 centimeter panchromatic and 81 centimeter multispectrum. And we can even deliver auto using our own super resolution technique for a 50 centimeter multispectrum or panchromatic product. They have 5 bands, panchromatic band, blue, green, red, near infrared. And we also have high revisit. At this moment, our first 15 satellites are providing 2 times revisit a day. One collection in the morning around 10 to 10:30, and also another collection at 1 p.m. in the afternoon. And with our next 6 satellite, which is in space right now, undergo calibration, we are expecting to have a revisit of anywhere on Earth 7 to 12 times a day. So I think we will be the highest revisit satellite image provider in a few months' time. Next, I want to talk about our high resolution because they have other capability that I want to share. One is that our SkySat is able to collect a stereo pair. This is done by collecting a forward-looking and a backward-looking over the same area of interest, and using the same satellite, as shown on your screen on the left. And then we can also capture in a specific angle, so that we can use photogrammetric software to extract the height information. And our user can use this stereo pair to produce a digital elevation model, as you can see on the right. We also accepting tri-stereo. It means we collect a third image over the same area of interest, near nadir, pointing downwards, and deliver 3 images over the same area of interest. This will help to improve the accuracy, and the third image can also be draped over the digital elevation model, DEM, to get some kind of a 3D model. Here is a 3D model developed by our partner, Keros. This is one of our partners in Europe, and they are using our stereo pair to create a digital elevation model. And they drape over the newest data satellite image over this open mine. This will give the operator a more realistic view of how the mine site is being operated, and also their surrounding environment as well. And this is usually done by satellite image because the mine is quite remote. Another capability of SkySat is that it has the ability to collect a video from space. Imagine you have your phone in space capturing video, like what you do for your YouTube. This is what our SkySat satellite can be done. We are using a CMOS framer as opposed to a traditional push-boom sensor, and we can capture about 50 frames per second creating a full motion video. We offer 30 seconds to up to 2 minutes video on our camera. And from there, you can actually see a lot of things moving. Okay, you can see cars moving on the roads. From there, you can check the direction of the roads. And you can also see all the landscape of the city. And even with this kind of video, you can use all the frames to create a 3D model of the city as well. So I want to wrap up by showing this video how our constellation works. First, we have our 3.7 meter planet-scope constellation forming a ring around the Earth and collecting data on our Earth landmass every single day. And we have our high resolution, the first 15 of them, in the same sun synchronized orbit and augment the high resolution. When you need a higher resolution, you can activate those high resolution satellite image. And we have our next 6 satellite orbiting at equatorial orbit, and it will give you a higher revisit up to 7 to 12 times a day to give you unlimited supply of data on Earth. Okay, with these assets, we Planet have 4 core products that we offer to our customer, and these include our Planet monitoring, Planet tasking, Planet base map, and analytic feed. For Planet monitoring is actually our daily collection using our 3.7 meter resolution planet-scope, and we collect it and hold it in a platform called Planet Explorer for user to view and download every single day. Then from all this image, we actually build our monthly base map or quarterly base map. We are offering a monthly cadence of base map because we think that with monthly cadence, we can get a very good cloud-free or near cloud-free image of the entire world. We are building the monthly base map for the whole world landmass every single month. And then we have our Planet tasking. This Planet tasking only applies to high resolution because, as I mentioned, our planet-scope monitoring does not require tasking, but it will collect automatically over landmass every day. For high resolution tasking, we offer multiple mode of tasking, including mono image, stereo image, and also video. And we can collect twice a day at this moment. In 1 or 2 months' time, we're going to have 7 to 12 times a day. And lastly, our analytic feed. Using our monthly base map, we think that there is a value for us to look into the machine learning and AI kind of technology to extract information from there at the monthly cadence. For example, on the screen, you can see roads and buildings are being extracted from our monthly base map. And comparing all these analytic feeds from month to month, we can sort of understanding the changes over the landmass of Earth. We are also applying our analytic feed on other objects like ships and aeroplanes on airports. This can be a daily feed to our customer who want to understand what are the traffic coming into the airports and seaports every single day. So next, I want to move on to another section, which is the Planet use case. Our use case covers everything that you can see on Earth, from defense and intelligence, civil government, agriculture is our big piece, forestry and mapping. But I would like to focus more on 2 important domains, which is the emergency management and also energy and infrastructure, mainly on the infrastructure part. So first, I'll talk about urban development and infrastructure monitoring. One of the common use of high-resolution satellite image is to do infrastructure monitoring, especially when it requires a large coverage and the cadence of collection. The place can be remote or is rather inaccessible to reach the place for ground survey. It often look at the development of construction, for example. This case is Japan National Stadium, which was reconstructed for the coming Olympics. The demolition of the old National Stadium was complete in 2015, allowing the construction for the new stadium beginning on December 2016. And here you can see 4 satellite image capturing at 4 different periods. From February last year, you can see that the stadium was almost, the structure of the stadium was almost complete, left a bit on the rooftop. And just a few months later, you can see the roof is already is completed, and you can see that the stadium is going green. There's some solar panel on top of the roof as well. They move on to, in November, they move on to the interior of the building. And this year, March, they already complete the stadium. And the exterior of the landscape of the stadium is also being polished up. And after you receive the satellite image, not only you can use that visually to compare, you can also use advanced remote sensing or GIS technology to perform a change detection. Here is an example of the change detection service done by our partner in China, EarthStar Technology. This is an area of urban area in Shanghai, China, and their purpose is to detect a newly constructed or demolished building and roads. They are using November and May 2019 satellite image. And SkySat have a good resolution to see most of the infrastructure in the city. And here you can see the report marks out the building, new building and bridges. Here you can also see the reports mark out the clearing of a spot field and the building as well. And not only that, our resolution can visually look, we can also use the spectral band, the four spectral band to perform land classification. Here, if the customer want to look at what is the land use using the satellite image, they can perform what we call a land use land classification using some of the technique found in some remote sensing software. Here, our partner are using object-oriented multi-scale segmentation and random forest classifier algorithm. And you can easily find a variance of this kind of classification in remote sensing software like MV or eCognition. And at the end result, you can find that we can map out different layers of land use. For example, here is farmland, forest, water area, residential area, industrial area, and others. And next, I want to move on another important kind of satellite operation that is up and coming. We call it tip and queue. So tip and queue operation can be done by Planet because we offer 2 kinds of resolution. Mid resolution at 3.7 at a daily rate of collection. So we have daily collection over the entire Earth, and we can use that to understand different parts of the Earth and see whether there is changes. Once you have accumulated enough changes and you want to take a closer look, you can activate our high resolution SkySat at 65 centimeter panchromatic to take a clearer picture. Here is an example of a use case, Bangsha Tar Island in the southern part of Bangladesh. Most people will know this area when we talk about Rohingya refugee, where they are settled down there in the refugee camp in this island. And there are many changes to the infrastructure because of the influx of people. And because it's a remote island, the government will have a lot of challenge to go to the ground survey to understand the changes. So they are using our satellite image, our mid-resolution satellite image to detect the changes. And once they know there's enough changes, they will activate our high-res to see a clearer picture. And from our high-res, you can see all kinds of changes there. And if you compare with 2 different satellite images, you can even map out all the changes. And in the case of emergency, satellite can also be a source of collecting first-hand information at scale. In this recent event happened on the 4th of August this year, most of you all will know 2,000 over ton of aluminum nitrate exploded in the port of Beirut, Lebanon. The blast created a huge mushroom cloud and shockwave that was felt as far as 150 miles away. It was registered as an earthquake, a 3.3 magnitude earthquake, and the explosion killed dozens of them, and thousands of them are homeless. And Planet also play a part in this because we are part of the International Charter and we are being activated for humanitarian support. So on the slide, you see an image collected a few days before the explosion. It was on 31st May 2020. It shows the warehouse where the material was stored and the surrounding infrastructure. And this is an image just after 1 day of the explosion. Because it's a tasking satellite, we only can activate 1 day after, we only collect 1 day after the image. And you can see some aftermath. There's a water-filled crater here. And there was also damaged solo container. And you can see a capsized cruise ship here as well. So the satellite image, by comparing two images, you can see the damage from there. Next, I want to move on to disaster support. As I mentioned, because we collect daily image over the entire Earth, our mid-resolution are able to support some disaster events like forest fire monitoring. I remember last year there's a big forest fire in Australia as well. Planet is also supporting this event. And just nearby our region, we also got seasonal forest fire in near Singapore. So for forest fire management, usually our user will use MODIS, or moderate resolution imaging spectral radiometer. It's one of the key kind of instrument in the NASA satellite Aqua and Terra. They are viewing the Earth every single Earth surface every 1 to 2 days, and they have a few spectral bands that is good to extract the thermal data. And the user are using this data to detect the hotspot. The table below shows a record of MODIS data. However, some these MODIS data are of accuracy of 1 square kilometer resolution, and it only gives you the latitude longitude. Sometimes it also gives you some false alarm due to some unknown heat signal on the ground, which is not a fire. And it also do not tell you the extent of the fire. So it's difficult for the firefighter to plan their resource in terms of manpower and equipment for their rescue mission. And Planet Image, our daily collection, can provide some help here to verify MODIS data. With our daily collect image over the world landmass at 3.7 meter resolution, our user use our satellite image to compare to MODIS data. And here, for instance, this record for MODIS data against our satellite image, the position of the forest fire are offset by 6 over kilometer. And from our satellite image, you can also see the extent of the fire as compared to a text-based MODIS data. So a picture tells 1,000 words. Here is another scenario where MODIS data indicate that there is a hotspot, but our image does not see a fire. So from here, we can even verify whether this is a false alarm or this is a true fire. And using satellite image, because it's all geo-reference, we are able to do a damage assessment report after the fire to measure the burn area, and for insurance claim and for authority to do the damage assessment. And here, with other weather information like wind direction of the day, we can also assess and verify the spread of the fire and also the direction of the fire. And in this case, if the fire is going to spread to a major settlement or city, we can use that to alert the settlement and evacuate the population over there. And we can also use many remote sensing techniques to automate many calculations of hotspots, and maybe to do automation in alert of forest fire and verify it. Here we can use NDVI to extract the vegetation index of the forest fire throughout the burning period. So this visually will look more appealing and easy to understand the extent of the fire. Another case study, this is tsunamis in Palu, Sulawesi, Indonesia. On the date of 28th of September 2018, I remember it's a Friday, we heard from the news in late evening there was a tsunami hit the island of Palu. Palu is the capital city of province of Central Sulawesi. And we quickly activate our SkySat and other satellite to collect image over this area. So the event is on the 28th, and we have a pre-event image. This is the Planescope data of Palu Bay on August 2018. And on the 1st October, this is what we have captured, and you can see the sediment in the sea. These sediments are caused by the tsunamis that push water into the inland and draw out all the dirt into the sea. And from these two images, you can really see the extent of this tsunami. And disaster response, we are quickly activate our high-res to give first-hand information to the authority. And good thing that we have a morning and afternoon pass to collect of our SkySat. As you know, Indonesia is a very cloudy region, just like Singapore. But clouds usually form in the morning and move away in the afternoon. And with to collect a day, we are able to collect one cloud-free image in the afternoon on the eastern side of the Palu Bay and provide the authority good information for their rescue mission. And we also capture a lot other areas and do change detection. For example, here is the bridge linking both sides of the bay. And this is before the event. And after the event, you can also see that the bridge is being damaged. So the transportation linking between two sides of the bay is being disconnected. And you can see there's a lot of damaged house near the shore of the bay as well. Again, we're also using remote sensing technology and techniques to do change detection and to assess the damage as well. Next, we also want to talk a bit on oil spill because in our region, Southeast Asia, there is a vast open water body, and it's also the main shipping line for shipping of oil from the Middle East to our North Asia region. So it's important to understand how we can support in the case of oil spill. So on the 25th of July this year, very, very recent, a Japanese-owned ship, MK Wakashio, carrying about 4,000 metric tons of fuel. And they struck the coral reef close to the coastal of Mauritius. And there was a large oil spill from the damaged ship, and the Mauritius authority are facing some challenge to contain it because they might not have the resource and it's still a bit far from their coast. And Planet also took many high-resolution imaging daily, okay, and supply them to our end user. Our end user is actually Japan government themselves. As you can see from the image, the oil began to leak on the 6th of August. And then the ship broken into two parts on 15th of August. And then after the state, the bow section of the ship was towed away into the open ocean. Okay, next I want to look at a more nearby case, which is happened in the north of Jakarta. The incident was happened last year, July 12th. There was an oil rig in the northern part of Jakarta, Indonesia, and during of this new well, natural gas was released and causing an imbalance in the oil rig. So it was spilling about thousands of barrels of oil into the sea. As you can see from the screen, the extent of it. The oil spill already reached the village of the coastal of Karawang. And you can also see that the extent of the oil spill here provided by the authority is as long as, I think it's about more than 80 kilometers long. So Planet also happens to have our daily image and quickly using all our satellite, both high-res and mid-res, to capture the whole incident and monitor the oil rig and the rescue mission for the next 3 months. Here is an image captured on the 2nd of July, okay, before the event. And this was the actual day when they reported there was an oil spill. Because our Planescope 3.7 meter satellite image is collecting every day, we just happen to have that. We just have that image of the incident. And from here, you can see the extent of the oil spill. And the next day, and you can see that the spilling is, the extent of the spilling is getting bigger and bigger. And here is a video clip of what we capture for the 3 months of event. And from July till September, and you can see all the boats are surrounding this oil rig to prevent the oil spill from extending and to contain and repair the oil rig. And here are some of the sample of high resolution as well to look at the clearer picture. Okay, I would like to end my presentation, okay, by stating the value proposition of Planet. First, we have the global coverage because we built very small satellite and launched a lot of them, 150 of them, and collect Earth landmass every single day. And we can augment them with our high revisit satellite, SkySat, twice a day for now. And in 2 months' time, we're going to have 7 to 12 times a day for high resolution. And we also got high satellite capacity, and looking at our numbers of launches, and we're going to have more and more satellite in space in the near future. We will definitely be able to provide continuous supply of satellite image to our user. And we also invest heavily in our analytics at scale. And for those that are interested, can go to our website and look at our analytic capability as well. Lastly, I want to make an announcement for all users to join our free virtual webinar. We call it Explore 2020, happen in October. It's a 2-day event. You all can really register at this URL, planetexplore2020.com. And for other information, you can reach out to our sales team at this contact URL. With that, I will go into the Q&A.
Thank you very much, Kian. I think that was quite insightful. So I think over the course of our presentation, we have had quite a number of questions already. So let me moderate this. So let me ask the first question, and this is perhaps to Kian. What is the, I've got a question here regarding stereo tasking. Are we able to produce 3D point clouds?
At this moment, Planet is only supplying the satellite image stereo pair, and we leave our partners and the user to produce the byproduct like DEM. But technically, when you produce a DEM, you can convert them into point cloud. But Planet do not provide this service.
Okay, thank you, Kian. All right, next question. So is there a minimum AOI size for each collection?
For collection, it only applies to SkySat high resolution tasking. Our minimum is 25 square kilometers per collect. And we also got a minimum width of 2 kilometers for each collect as well.
Okay, thank you. I hope that answers the question to the audience. And there is another question. So how long does it take from collection of SkySat data to the data being available to customers?
Yes, we have a different program for SkySat. For higher priority, for standard, we can deliver up to, operationally, we can deliver up to 10 hours upon collection. So we have 2 collects per day, 10 to 10:30 in the morning. So you will get your data around 10 to 10:30 p.m. At night. In the afternoon will be slightly later. But for PlanetScope, because it's a daily collection, you also get around 10 hours latency. However, for some customer with priority, we can get panchromatic data at 3 hours, as soon as 3 hours for level 1A product.
Okay, thank you. All right, one more question here. You mentioned that most of our image are of the land mass, but it seems that there is some coastal data that is captured. How far out from the coast are we able to capture in our monthly image sets?
Yeah, usually we try to extend out from the landmass about 15 kilometers, but it's case to case. especially the smaller islands. We don't extend too much on the small islands, but on the usual country border, coastal border, we will extend about 15 kilometers. And we also are actively using our PlanetScope to collect about 20% of the ocean. And you can refer to our website to download the shapefile where we covered in the open waters. It's usually from our main shipping line from the Middle East all the way to China and North Asia region. It definitely passed by the Strait of Malacca.
All right, cool, thank you. And another question regarding, for data near the equator, how do we deal with thick cloud cover?
Yes, very good question. So we are optical satellite. Optical satellite will have problem with cloud because our sensor do not so-called penetrate through cloud. This applies to all satellite providers as long as they are optical. What Planet do is that we have a strategy to launch enough satellite to collect data every single day. That is for our mid-resolution. And if you over a week, you definitely can see some kind of good data, cloud-free data over your area of interest. And for the high resolution, we currently have 2 collect per day, one in the morning, one in the afternoon. And hopefully the cloud moves and we are able to give you at least 1 good image over the single day. And in the near future, we're going to have 7 to 12 times a day. And hopefully we can get good image. And if we can't collect, I don't think any other satellite provider can collect a cloud-free image over this tropical country.
Yeah. So to add on to that point as well, so imagine the possibilities that we can have after we are going to increase that revisit capability from currently twice to up to 7 and even some places 12 times in a single day. So you could really monitor change as it is really happening on the ground. So imagine the possibility. So there is this other question that I want to come back to. Can I use satellite imagery to monitor illegal logging? So the answer to that is a resounding yes. In fact, this is one of the use cases that we see a lot of NGOs or big government organizations that are looking to monitor the forest at scale. So you have millions of square kilometers spread across. How can you send people out there? Or even it's expensive to fly drones, expensive to fly manned flights over to watch over your forest. So satellite imagery, Planet, we are imaging every single day. So the data is there. These illegal logging is something that we always try to push for as a use case, and we see more and more customers actually coming to us to use our data to augment and to really add on to their current workflows and to provide a complementary set of data to monitor all those activities. So on top of that as well, we do, like I've mentioned very briefly during my portion, agriculture is a very big thing, and in this region, agriculture is one of the very big strong use cases that we see coming up. As well as urban planning, public utilities planning, monitoring of infrastructure. It's with satellite imagery, you're able to do that at scale, very efficiently, and at a much cheaper cost versus sending boots on the ground or taking drone imagery. So these are just some of the use cases, and feel free to reach out to us if you have any questions or you'd like to apply them to your use case, your project. So yeah, that's the question. I think there are a couple more questions with regards to DEM 3D imagery. What is the accuracy that we have, Kian?
Yes, for accuracy, our geolocation accuracy is about 10 meter root mean square error. And our height accuracy depends on the collect, whether it's a 2 stereo pair or 3 stereo pair. We can do a few meters of accuracy. Unfortunately, I can't comment too much on that because Planet do not do the DEM ourselves. Our partners do it. We only provide the raw material. If you are interested to link up with our partners, to connect us using the URL as shown on the screen, and we will point you to the good partners that can in our region to do the DEM.
Okay, thanks very much. So I think with that, I don't think there are any more new questions coming in, and I hope I've managed to answer some of them in the Q&A box as well. Yeah, so if there are anything else, we hope that this gives you a bit of a better idea of what Planet does, how we're actually using our data, what can our data be used for in many different types of use cases. Feel free to reach out to us, and if you have any more questions, any more something you'd like to explore more in detail on your project use cases. So we thank you very much for your time. We don't want to take out any more time before lunch for you guys. And once again, thank you to GeoWorks for setting this up and inviting us to be a part of this amazing GeoPlus week. Thank you.
Okay. Thank you so much, Jonathan, Kang, Kian Hong. Thanks for the presentation and the question and answers. So once again, to all our audience, do check out Planet's user conference in the link that is currently shown on the screen. And also at 2 p.m., do join us for the industry panel, for urban and environment. Planet will also be there for the panel discussion. So just do register if you have not registered, and do join us for the industry panel. So without further ado, thanks once again. Thank you so much to both our speakers. Thank you to Planet for participating in this webinar. And to everyone else, thank you so much for participating, and we'll see you again in the rest of our other summit webinars. Sorry. Okay. So once again, thank you, and see you again. Bye-bye.
Thank you.